Hello, I would like to review your code with you. It was very good. We need to make some changes in the organization. I tried to correct the description in the overleaf document. It is true that you will be computing these four quantities. Each one of these quantities is a vector. You will be computing these four vectors for several iterations. So that means that you're going to create a matrix of results. Each row of the result will have LZ, AZ, LX, and AX for one particular simulation. But there will be n iter simulations. So you will store your results in a matrix with n iter rows, and in each row the size is n, where n is the number of bird species in that environment. So your function will return four arrays. Those four arrays will all have the same size, and you can return them in a list. I'll show you that in the code. Then with that output, you will create a dictionary so that the results will be organized. The dictionary will have two levels of keys. The top level of keys will give the location, like Bombascaro, Canjanaro, places like this. The second level of keys will give the name of the array. Right. So, for instance, to reference one array would be something like this. You'd have the dictionary's results. Then here we would have Bombascaro, and then under that you would have, for instance, AZ. And that would be an array of values. Now, I have not defined this yet, but that's how you would refer to the results. All the results will be listed like this. So this would be an array of values, right? So let me go through the code and show you the changes that still need to be made. All right, first of all, we do need to define the number of iterations, so I put that in first. Here we have the site names, and they're arranged as a matrix where each row corresponds to a different altitude and the two columns correspond to different fragmentations. Okay. So it's good to store the site names in this way. Now we're going to put the results in a list of lists, and it's not going to be the same size. I shouldn't say that. It's going to be in a dictionary. It's not in a list, it's in a dictionary. As I said, there are two levels of keys. The top level key will be the site name. The second level key will be the array name. Right? So you will need to loop through the site names, and you can do that by doing a pair of loops. This will loop over the rows, this will loop over the columns, and then this will give me the site name for that particular site. That will enable you to choose the dictionary for that particular site, which you will pass into your function. Right. Now, the function will give you a list of results. So, in fact, I should have written, instead of saying list of 0, this would be simlist. Right. So the final result for LZ, AZ, LX, and AX will be these lists. Sim list of 1, sim list of 2, and sim list of 3. Okay. All right, so that will be our results. Now, let's go down and look at the function. All right. So we have these print statements. So of course, we'll remove that afterwards. This is good. We need the number of bird species. So I'll put that as a comment. This is the number of bird species. Sorry. Okay. Now you define this, this array M. It's better not to do it this way. It's better, as I said, to define 4 separate arrays for the 4 separate vectors that we're interested in. So I did 1, you can do the other 3. And then here you have this exponent, which is fine. All right, now we're going to do the iterations as you had before. And the computations here are fine. We should remove some of this code. Now, this code here, I replaced this code. Oh, let's see. All right, so I commented these code lines out. It's not necessary to replace the values in the dictionary because each random simulation is going to give you different Zn and Xn. So it's always changing. There's no need to save the values because they're all randomly generated anyway. Okay. Now, here you have a code to replace zeros with ones. So your code went from here to here. This is a much simpler code. The way to replace zeros with ones is simply take your previous array here, and this statement, whenever Zn is 0, it will replace it with a 1. All right, so this code here for Z and XF replaces this code here. So you can remove this code. I just kept it so you could see the difference. All right. So again, it's not necessary to change the dictionary, so you can remove these lines as well. All right. So here we've got this. This is all very good. You got the model. Now, when you do the regression, you need an intercept because the intercept is the value of C0. If you say fit intercept equal false, then you would have C0 is always going to be 0, but you want to have a non-zero value of C0. Okay. Now, when you run a single simulation, that will give you values for LNZ, ANZ, LNX, INN. That's good. Each one of those is one vector. Okay. But that vector will become a row in an array. These arrays would be defined up here. So you need to put each vector and a row in the array. So you put in the array up here. All right. And then in the end, outside of the loop, you would return these 4 arrays. Okay. This is showing a mistake because I didn't finish defining the arrays. The other thing that needs to be done, besides fixing the arrays here, is to fix the output. Well, actually, I think I did fix the output here. Okay, so this code, once you fix this code, it should be ready to run. You can run and see if there are any mistakes in it, and we can continue to go further. Okay, so this code will be in Dropbox as new simulate.py, and you can take it and modify. Okay, very good.